Y'all ready for this? Y'all ready for this?
Good morning. You've seen me at this location before. I'm Joe Guzzi, Division Engineer, Mid-Atlantic Division at Zoo Interlocking, gateway to the Harrisburg line. Fastest growing corridor on Amtrak's system. Amtrak Engineering is entering into Phase 2 of the Keystone Corridor Rehabilitation Program. During Phase 1, we completed the installation of 65 miles of concrete ties, complete reconfiguration and installation of concrete turnouts at Cork Interlocking in Lancaster and Roy Interlocking east of Harrisburg. Engineering forces completed the installation of wood ties between Downs and Park and Roy and State. We have surfaced and ballasted hundreds of miles of track in order to raise the track speeds to a maximum of 110 miles per hour. On the bridge and building side, we've installed interlock lights, made platform improvements, all of which has contributed to higher speeds and reduced trip time and a smooth ride. A few years ago, this corridor rehabilitation program was just a dream. Now it's a reality. Stay tuned, hang on to your hard hats, because we're not stopping now.
We're here at Cork Interlocking, and the production mission here is to completely rehabilitate a 1930 vintage interlocking, installing concrete ties, concrete turnouts, and also to install a freight bypass track which will allow the freight service to pass the station without interruption to our service. Also, we have to align both 1 and 2 track back to the platform to conform with the new plan for the Lancaster station.
I'm standing in front of Conestoga Interlocking House. This house, as all other houses for Cork Interlocking, were wired in our Lancaster signal shop. And what we're doing at Cork is we're breaking it into 4 separate interlockings. We're going to close the tower. Each interlocking will be remote controlled from our CTEC dispatching center in Philadelphia. We're eliminating air switch machines which were unreliable, replacing them with electric machines. We'll have all new signal houses, new cable. Between Cork and Roy, we're also installing a new automatic block signal system to provide bidirectional running on each track. The line is currently signaled for one direction only. With bidirectional signaling, it'll provide more flexibility, and we'll be able to run around track outages and other work that's being done much more efficiently. Roy Interlocking is also has been done, new switches, new electric switch machines to replace the air machines, and Roy will be going into service later this year. When this project is finished, we will have over 1/3 of the Harrisburg line reverse signaled. It's signaled for both directions on both tracks. We'll have a new radio base station system that is up to date and in compliance with FCC standards. And we'll have a fiber optic communication system from Philadelphia to Harrisburg.
We're standing in one of our 12 substations on the Harrisburg line that supply the catenary power for our new electric trains that'll be running here in September. This substation has had 5 new breakers put in. We still have 2 transformers. There are low sides and associated high side equipment to do as we continue with the rehabilitation of the electric traction department. Approximately 72 circuit breakers. We've done 30 of them thus far on this line. There are 23 transformers. We've got 1 of those done, and we'll continue doing those over the next few years. There's about 205 miles of catenary. We're rehabbing that at the interlockings at this point, where the new interlockings are going in, and we're putting in new switch heaters at all the new interlockings.
We are currently in our 3rd year of a multi-year program rebuilding the Harrisburg line from Harrisburg to Philadelphia. We've made great strides in renewing the rail, surfacing the track, installing ties over the last 3 years. For years, the Harrisburg line was neglected due to lack of funding or other priorities. In the past 3 years, we've renewed the rail, renewed ties, surfaced the track, rebuilt interlockings. Today, the Harrisburg line is a model for future corridor work in Pennsylvania and other states.
TLM this year had the opportunity to work on the track between Paoli and Penn, and we're now working on the from number 4 track from Baldwin to Holly, and then we're going to be doing the tracks in through Wilmington Station on 2, 3, and 1 track down there. So we really feel proud about the accomplishments we've done for the year, and we're looking forward to working on the SEPTA contract in FY07.
I want to talk to you about some of the obstacles and challenges we've had to deal with this year. This is my 4th year with TLS, and this has probably been the hardest year that we've had so far. The Harrisburg line, we dealt with interior tracks, close clearances, poor tie conditions. There were days when we would throw out more ties sometimes than we put in, upwards to 250 to 300 a day. And on top of that, the access on the Harrisburg line is minimal at best. And it was a real challenge just logistics-wise to get the job done. Overcame all of those obstacles, and now we've moved out to the main line and just think it's going to get a little easier. In this block between Baldwin and Hook, we've had to deal with numerous open deck bridges, which involve cutting the TLM out and then back in. We had to get everyone used to the new, not the new high-speed trains, but getting used to high-speed trains again.
Behind me here, we have one of our typical days that we've been running to since we've been working on this stretch. It's a cut in, cut out, tilting tires by hand constantly all the time with situations like this. There's a lot of physical labor what we're doing here on this operation, lifting the plow up by the operator himself to get underneath the plow to dig, because the ballast has to be somewhat kind of level for the concrete tires going to the approach of the bridge. A lot of guys have to be careful where they're walking at all times. Situation can be very treacherous out there because tires constantly got to be pulled out. You can't constitute a tripping hazard, slipping hazard.
I'd like to really wish everybody a happy Thanksgiving, a Merry Christmas, and a happy next year with all your construction and your division work. And I really would like to say thank you to everybody within the Amtrak family.
Welcome to the B&P Tunnel.
This cable project is about a $20 million project when it's through, replacing the old oilostatic cable. The oilostatic cable was installed in 1932 and has fulfilled its useful life, and here's been prone to as far as failures. Each of those failures not only impacting railroad operations cost between $250,000 and $750,000 to repair and clean up. So this new cable, even though the circuits, by the time we get through with Union and B&P Tunnel, will be close to $20 million, will be a long-term savings over the end.
The replacement and complete removal of the oilostatic system is a 4-phase process. We are currently in phase 2 of the 4-phase process. The additional phases, phase 3 will be completed in FY07, and phase 4, which will eliminate the entire oilostatic system by replacing it with the dry cable system, will be completed in the FY08 year.
We're here at manhole 8, where we're pulling in the new 121 circuit of the solid dielectric cable. You can see as far as the cable's being fed into manhole 8 and being pulled towards manhole 6 in the Wilson Street Tunnel. The conductor is about a 750 MCM conductor with about 3.5 inches of insulation around it that replaces the old oilostatic cable, which was high pressure and only about 2 inches in diameter. On completion of these pulls, we'll begin testing the cable as far as the end of August so we can energize and have the circuit back in service before the end of our physical year on September 30th.
What we're looking at is the finished product for the CNS duct bank. The duct bank was included in the B&P process. The bottom pipe is an express pipe that was not included in the project. Eventually we will pull the 6900 volt signal cable through the express pipe and remove it off the wall. New CNS junction boxes. Original construction had those junction boxes mounted in line with the conduits down on the face of the transmission duct bank. We've moved those up and on the wall to get them out of the water area, keep the cables dry. Those junction boxes will house 64 pair trunk lines that control the track circuits and the CNS signaling through the B&P tunnel. Since the beginning of the project on October 21st, the Amtrak employees have been injury-free and incident-free on the tunnel projects. I feel the reason for the injury-free streak that we have had is the professionalism in the employees and the way they do their job, and the professionalism in the job briefings that they hold.
Hello, my name is Tom Beam, General Foreman here at the Wilmington Roadway Equipment Shop. Here at this facility, our task is to repair both small and large equipment through capital programs in a safe and efficient manner. Why don't we go on board and look at this catenary inspection vehicle? As you can see, the condition of these cars when we get them, it's pretty poor. This car here is about 10 years old. It's got a lot of service hours on it. As we walk the car, the floors are wore out, the cabinets are wore out. We go soup to nuts on this, replacing everything. We gut it to the walls. We remove the bathrooms, we replace them with lockers. We remove the gig top and the pedestal, and we replace it with extra lockers and needed shelving. Cabinets are in pretty bad shape. Countertops, we replace all of them, go through with the table and the benches, have the benches reworked, replace the seats, some glass, repaint the whole interior. Like I said, floor to ceiling. We completely rebuilt the telescopic cylinder for the platform and all the valving. The pantograph is replaced. We coat the roof and make repairs as needed on the roof. We completely overhaul the Powfinger cranes, have them inspected by an outside concern. Brand new countertops, brand new flooring, brand new seats, operator's chair, everything. Microwave, refrigerator. Here we are, the center section of the catenary inspection vehicle. I call it the meat and potatoes room. This is where you get everything done. Brand new vise, brand new drill press, brand new grinder, brand new cabinets, extra storage space. We installed new man lockers. We replaced the engines, trans, torque converters, trucks. Capital project, capital product.
The reason why we've been able to achieve the milestone of working 1 year injury-free, it isn't because myself or the managers dictate that it has to be. It's because everyone that works here in the shop has taken the responsibility for themselves to work safely. All that we can do is support these guys with what they do each and every day, try to make the environment as safe as possible, and provide anything and everything that they need to perform their jobs safely. And that's the only way we can reach our goal.
What's our purpose? Our purpose is to get work done. Through constant communication, collaboration, and commitment to the process, we will have teamwork. We will get it done. We'll get it done safely and on time.
The employees here at the Wilmington M&W facility take a lot of pride in what they do. They deliver a quality product and they do it safely.
Amtrak's 10003 track geometry car. This vehicle, you hear the term track geometry car, but what it actually does is it measures the geometry of the track. This is a vehicle that's used as a tool to measure what the track conditions are, and the maintenance personnel then take those measurements and use them to set up their maintenance plans, look for safety defects that may exist in the track that they would have to address immediately. The information that this car provides the track department is useful in terms of planning for track surfacing. It's also useful in terms of capital projects for long-distance trending analysis of the railroad conditions and for planning future construction work. The car measures all the parameters of the track conditions. That's the gauge, which is distance between a rail, the super elevation, which is the banking and the curves, the curvature, the profile, which is the surface bumps and dips, the alignment, which are the horizontal wiggles of the track. And it takes those measurements at speeds up to 165 miles an hour, does a measurement every foot. And these measurements are then referenced against the MW1000 standards for maintenance and also the FRA standards for safety.
In September of 2005, we have created a program to interface with the geometry car hits on the Northeast Corridor. To date, we have surfaced over 800 miles. The remaining 214 miles are new construction. New construction could be switch installation or track panel installation.
Okay, what we have here is Plaza's latest version of the Dynacat tamper. It is a 16-tool continuous action production tamper with switch capability and a built-in stabilizer which allows you to stabilize the surface at the same time. And on any given night, depending upon track usage, we can service anywhere between 6,000 and 8,000 feet per night with the limited windows that we have.
We're at County Interlocking in the New York Division. We're using the 094S continuous action Plaza tamper to do the work with. Right now we're doing the switch mode in new construction, and It has many different features. One being that the heads on the tamper spread, where he can tamp all parts of the switch. He has an arm extension that comes out to help lift up the long timber side of the switch. Usually when they're doing the maintenance part of it, they're in continuous action tamping mode.
Earlier this year, we got a program together to eliminate mud spots. Basically, we're using the vac train. We've done about 100 spots now, just because FRA was writing us up for our mud spots. And we were having level 1 and level 2 geometry defects. Hopefully, by us using the vac train to vacuum these mud spots out and using our surfacing unit behind them, dragging stone, fresh ballast, and surfacing them up, hopefully we'll keep the speed restrictions off and be able to keep our trains on time.
We're working here on number 4 track between Baldwin and Hook. We're basically, over years of neglect here on 4 track, we're trying to establish the profile and alignment back here so we can raise the speed on this track. And here we are. We cut yesterday, cut about 637 feet the first day after moving in here. Basically, you can see behind us now, the undercutter's working, getting a lot of dirt out of the track now. Got the surfacing gang behind us coming in now just to start, and have a dozer right behind us to level off the spools where we're dumping them here on the hill.
Hello, I'm Steve Allman, Amtrak's Program Director for the Fire and Life Safety Projects here in New York City. Amtrak and our partners, Long Island Railroad, New Jersey Transit, and the FRA are currently undertaking a program valued at $472 million to upgrade existing fire and life safety systems, construct new systems here at the North River Tunnels, the East River Tunnels, and the New York Penn Station complex. Why is fire and life safety important? Every day, over 500,000 passengers move in and out of Amtrak's New York Penn Station through 7 tunnels on 1,200 Amtrak, New Jersey Transit, and Long Island Railroad trains. We must ensure that we have modern systems in place to handle emergencies when they occur. Connecting New Jersey and Manhattan, here beneath the Hudson River, are 2 separate tubes known as the North River Tunnels. These are about 2 miles long and feature connecting cross passageways. Manhattan and Queens are connected by 4 tubes, the East River Tunnels. These are also about 2 miles long with connecting cross passageways between each pair of the 4 tunnels. The mission of our program is to safely deliver a high-quality, state-of-the-art fire and life safety system at Amtrak Penn Station and the adjacent tunnels without interfering with train operations or disrupting neighboring activities. The first project we're going to visit today is a tunnel ventilation project located in Weehawken, New Jersey. For this project, 2 new 60-foot vertical shafts were built connecting to the North River tunnels. The existing stairways were replaced with wider stairs with landings. New fire suppression standpipe was installed, and 500 horsepower bidirectional fans were installed and are controlled by the centralized computer system from Penn Station Control Center in New York. The new structure was built at the top of the shafts to house the new fans, the new utility systems, and provide access to the new stairwells. The existing floodgates at the East and North River station portals were installed in 1940 with the intent to protect the Penn Station complex in case of a catastrophic breach of the underwater portion of the tunnels. The floodgates fell into disrepair in the 1960s and were subsequently removed from service. This project brings the floodgates to a state of good repair for the first time in decades. We are refurbishing the floodgate system by installing a rate of rise sensor to monitor rising water. This will be remotely operated from the Penn Station Control Center. I'm just one of the many dedicated Amtrak employees working on these projects. With over 500,000 passengers traveling in and out of Penn Station every day, their safety and security is Amtrak's priority.
The switch exchange system is activated for 2 purposes: interlock and reconfiguration and interlock and rehabilitation. Interlock and renewal is initiated with a field survey for final design. Once the final design is complete, the field surveyors lay out the new switch point locations and the proposed alignment and profile. The switch exchange system is designed to load previously assembled switch panels without deforming the original constructed condition. The switch is then transported and installed with no evident fatigue to vital components. This system accomplishes this by lifting with equal vertical pressure. Existing track is cut. Existing track is removed. Cavity is excavated. Switch panels are installed. Ballast is distributed. Track is lined and surfaced. The 37 switch installation in 2006 is a milestone unachieved in previous production seasons. The switch exchange system has successfully completed 37 installations in the 2006 production season without a reportable injury.
This is County Interlocking. It's located in New Brunswick, New Jersey, on Amtrak's main line near milepost 32 between Newark, New Jersey and Trenton, New Jersey. About 2 years ago, this interlocking was one of the worst riding interlockings on the division, where we have 23 high-speed interlockings. The goals for this project were to eliminate the surface track conditions with new advanced technology, concrete turnouts. One of the added benefits of capital investments is the return on the asset with reduced maintenance costs. In 2004, we had in excess of $600,000 annual maintenance cost here at the interlocking, primarily maintaining the signal system and the track structure. One of the key things that we've been focusing on, and I think we've shown improvement in, is safety and productivity. Putting safety first around our work plans, having a safety component to the project, planning it out, and then carrying out a good communication plan, as we've been able to do here on the county project with weekly progress meetings, getting everybody around the table.
Hi, my name is John Kremp, Assistant Engineer, Electric Traction, New York Division. Right now we're at sub 42 Hackensack, milepost 3 on New York Division. As you can see behind me, we're replacing the #1 power transformer. It's been here for probably 60 years. It leaks, and we're removing the bushings and the conservative tank on top with a big crane. We're going to replace it with a new PTTI transformer.
We're here at sub 42 as far as part of the process replacing the last of the 4 transformers here. In the process, we replaced not only the transformer, but the low side breaker, the high side switch, and replaced the old mechanical relays with a solid state relay that not only gives us time and date stamp for an outage if we do have one, but trending analysis for voltage and current. And it's a great improvement for trying to analyze when we do have issues on the railroad, or looking for load flow information, trying to monitor when we put new trains on or add trains into the schedule.
Amtrak's 5-year capital plan for engineering includes several significant projects to our passenger rail stations here on the Northeast Corridor. Among these is BWI Rail Station here south of Baltimore, where Amtrak forces are rebuilding the southbound station platform. The BWI station platform project actually started several years ago, starting with the design, then getting permits because we are next to a wetline area. Construction started in 2005. The project involves demolition of the entire 1,100-foot-long platform and reconstruction of the support piers, installation of new precast beams and platform slabs. We'll also provide ADA compliance with a new concrete tactile along the edge. This project will be completed in early 2007.
Mass transit is absolutely critical to our economy and to the quality of life in the Northeast. It helps us save gasoline. It helps us to comply with environmental quality regulations. It's critically important. And construction of this facility allows both Massachusetts and Rhode Island to work together to extend and enhance mass transit throughout our region.
Hi, we're at the Pawtucket Layover Facility, and Amtrak is a contractor to the MBTA. Amtrak work scope includes a number 15 crossover at the west end of the facility, 1,200 feet of track from that crossover to the ladder here where we're standing, 4 number 8 turnouts here, and 1 number 8 turnout at the east end of the facility opposite where we are, and the number 10 Spring Frog turnout on the main line is an escape route. The MBTA is initiating this project to move their facility from the current location in East Junction, Attleboro, Massachusetts, which is in a residential area. During the winter, the MBTA keeps the locomotives operating, and there's a lot of noise and exhaust from those, which irritate the neighbors.
Eyes on me. 1, 2, and 3. Perfect. Fine, we got it.
The Rhode Island DOT Freight Rail Improvement Project is a project to provide 22 miles of improved vertical clearance to allow tri-level auto racks from western and eastern United States into and out of the port of Quonset Point. And we recently ran the first tri-level auto train on October 2nd. In order to achieve the necessary vertical clearance, the track was lowered under numerous highway bridges and 2 railroad stations, retaining walls, and the raising of the highway bridges. 17 miles of new or rehabilitated track with detectors, concrete turnouts, advanced technology crossovers, and 2 new interlockings were constructed. 2 existing interlockings were also reconstructed. Benefits of the project include increased capacity of the rail line from Providence to Davisville, and it minimized conflicts between freight and passenger traffic.
Among the highlights in the 2006 Capital Structures program includes the Thames River Bridge behind me, which is located between New London and Groton, Connecticut. We've started construction on the bridge. It's a 2.5-year project. It's going to cost us roughly $76 million, and we're going to replace the bascule movable span and construct a vertical lift span. We are replacing the movable span at Thames because of the growing risk of a severe operational failure of the trunnion bearings, which would result in the bridge to be stuck open for a long time. This would shut down the railroad and also close the river to marine traffic, which includes submarines from the U.S. Navy's submarine base at Groton, which is located upriver from the bridge. Planning for this project started over 10 years ago, when design was begun by Amtrak's consulting engineer, HNTB, out of Kansas City. After careful evaluation of proposals from the contractors, the job was awarded to Chimbro Corporation out of Maine, and they immediately began getting their fabrication subcontractors on board. The new vertical lift span and the lift towers require over 5 million pounds of fabricated steel. So far, Chimbro has constructed 2 cofferdams and also installed new foundation shafts drilled nearly 200 feet down into bedrock. The 2 bridge piers that will carry the new lift span are being modified and enlarged with reinforced concrete. This past June, the 3-story bridge operator's control house was moved overnight to get it out of the way of the new lift towers. We've gotten a good start in 2006, but much of the work will be done during 2007. The end result will be a modern and reliable movable bridge, which will serve Amtrak and our rail passengers for many future generations.
Construction projects that we've had ongoing on the Western Division this past year. Most of it's been centered in the Oceanside, Southern California area. Right behind me now is a bridge replacement project that was overseen by John Eschenbach, who is our project manager, responsible for the on-call services contract for the North County Transit District and Sandag. We also have a project further north, which we'll be looking at, that is putting in a double track between O'Neill and Flores.
Here in Carlsbad, California is Bridge 230.6. The existing timber trestle was constructed in 1948. This is the Los Angeles to San Diego rail corridor, known as LOSAN, the second busiest rail corridor in Amtrak's system, carrying the Pacific Surfliner trains. Also, coaster service between Oceanside and San Diego, California. This is a new 200-foot span concrete structure, 3 spans, a 100-foot span crossing the lagoon and 2 50-foot spans on each side of the lagoon, replacing the 1948 timber trestle, which has been damaged by marine board. Extensive environmental permits were required to protect the sensitive lagoon that the bridge spans. In addition to the environmental permits, utilities would need to be relocated. The MCI communication line would have to be moved off of the old timber trestle and mounted onto the new concrete spans. Right at the completion of the new structure, the embankment fill was compacted, sub-ballast placed, and bottom ballast. At that time, concrete ties were placed 2 foot on centers with 136-pound CWR. Saturday night will begin